Okay, so we're here. We're at the last lesson.
That's so emotional.
It is, isn't it? So here is what we had to have. So here is the observed values that we had. These are your expected values. Remember that the check for the expected values is that the row totals and the column totals should be precisely the same as the ones that you had previously. So that is always the check if any of these are different. So it's always worthwhile to add these together, right? If these are there's a problem here, you can then check the values that you've got there, okay, and correct it. Then the contributions should be these values here to get you a grand total of 27.74. Okay, so if you've got to that, excellent. So that means that all of those values and cranking the handle has worked. Now the actual hypothesis test, remember, begins with two stock statements. One, the null hypothesis, saying that there's no association between musical preference and age in this case. There's no underlying distribution to talk about. So there's no kind of let so-and-so be this at the start. So H0, no association. H1, the alternative, is some association between musical preference and age. So they are always the same stock phrases for the hypothesis test for chi-squared. You then need to get your critical value. So I would make sure that you've written down the degrees of freedom at some point as 4. Okay, so the degrees of freedom, remember, is subtracting 1 from the number of columns and subtracting 1 from the number of rows and multiplying those two numbers together. So that leaves you with 2 by 2, so that makes the 4. You go to the tables, 5%, look down till you get to nu is 4, and then you get the critical value of 9.488. And because your value is greater than that value, your value is in the critical region, and so you can reject the null hypothesis, and so there is evidence to suggest that there is some association between age group and musical preference. Okay, you've got to make sure you're talking about association here and not correlation. Okay. Now, the next bit has come up on a number of past papers. Okay, so this part 2, and could often carry 5 or 6 marks. So in the grand scheme of S2, that's a grade, right? So is asking us to discuss briefly how musical preferences vary between the age groups, as shown by the contributions to the test statistic. So our job here is to use the observed, expected and contribution values to make some judgments. So, easiest way to do this is if I put everything onto one page so you can kind of see where everything's at. Okay? So the first one that you might look at, because you should look first at the contributions table. The larger the value in the contributions, okay, the more important it is, the more it is contributing, okay, and the bigger the difference between the observed and expected values. So the larger these values are, okay, the bigger the difference between these two. So what we'd be able to say is this one is corresponding, that's quite large, okay, it's corresponding to 40.992 for expected and 57 for observed. So we observed quite a number more than we expected for that group, okay? Whereas, if you look at the 7.77, that's quite a large number as well for the contributions. We've got 39.528 and 22 here, so we expected far more over 50s to prefer pop than we observed, okay? So if you were going to write that down, you want to talk about in your answer using the exact values. The contribution of 6.25 implies that there are far more under 25s who prefer pop than expected. And the contribution of 7.77 implies that there are far fewer over 50s who prefer pop than expected. Okay? You need to make sure they're in words. You need to make sure that you are talking about the contributions. Okay? It is very explicit, the mark scheme for this. So let's have a look at some of these other values. Okay, so that'll get us a couple of marks. So if I look at the 4.51 and the 2.94, those numbers aren't so large as the 6.25 and 7.77. They go with those values there. So we can see that the expected are both lower than the observed values. So we expected fewer in both of those cases, or you could say that you observed more. So contributions of 4.51 and 2.94 imply that there are more over 50s who prefer classical and jazz than expected. Okay. What about the 2.70, 3.30? Well, they go with these guys here, and you can see that the contributions of 2.7 and 3.30 imply that there are actually fewer under 25s, because we expected this, but we got that. Okay, so we actually observed fewer than were expected under 25s who liked classical and jazz. The values that are quite close to 0 here for the 25 to 50 group, okay, you could then say that because those contributions are low, that would imply that their musical preferences are as expected, okay, if they were independent of one another. So it's a bit wordy, right, your explanations here. But because it carries a good number of marks, you just really need to make sure that you offer up the 5 or 6 bullet points that will go with and describe what you're seeing. It's quite a straightforward thing to do, but you just need to make sure you get your wording right and use the values and refer to the contributions by number in your sentences. Okay? Now, I'm going to show you the mark scheme for this question. This was, I can't remember the exact year off the top of my head, but I think we were around about 2006, 2007. So it's one of the first S2 papers, right? And I'm pretty sure, I'm pretty certain that what they've got here is not now how they would expect the answers to be written. Because in this answer, it talks about, rather than just saying more than expected or less than expected, it talks about a positive and negative association, whereas in a later paper, in the mark scheme, it specifically states that you shouldn't talk about positive and negative association. Now, I'm going to clarify this with MEI, because we saw this last year. I would make sure that I think this one was a blip. Okay, the rest of the paper mark schemes that ask this style of question do not refer to positive and negative association in their answer, and just compare the observed and expected frequencies. So I would err on the side of caution and don't use that as a model answer. Okay, I think it was 2006, one of the papers there. Right, I've got one last thing to mention, and then that's it. Okay, for this. And there is a possibility in one of these questions that you've got to deal with a small expected frequency. Okay? If it turns out that when you've calculated the expected frequencies that 1 is less than 5, then that is kind of like the point at which this test starts to fail, okay, and cannot be relied upon. It's not whether the observed frequencies are less than 5, it is just the expected frequencies, okay? So if that happens, then what we must do is we must combine some categories in the table in order to deal with that. That is the go-to way of dealing with this situation. So as it says, when the expected frequencies are very small, the approximation becomes less accurate, okay? So, I'm going to show it through an example. A market research company want to investigate whether some mobile phone operators are more popular in certain age groups. 400 people were asked which mobile phone operator they used, and the results were as follows. Okay, it's a big table, right? So, if you were going to do this, obviously it would take a long time to turn this into expected and contributions, right? There are some questions that will get you to combine a couple of columns, and then it reduces down to an easier one to work with, okay? So that could happen. In this example, there's nothing wrong with this data until you get the expected frequencies. And there is one expected frequency here that is less than 5. So 60 and over uses a virgin. Okay? Now, how are you going to deal with that? So the idea is that you combine columns or rows. So you've got a choice. Do you combine those two rows, or do you combine two of the columns? Now, which one of those two choices would be the most appropriate, do you reckon? Have a talk with the person next to you. Which one do you think is more appropriate? Right, okay, so are we going to combine rows, or are we going to combine columns?
Rows, definitely rows, 100% anyway.
Going to go with rows?
Yeah.
Well, if you combine the rows, you'd have 40 and over as a grouping for age, which does seem quite large. And that would be like the problem that you would have there. You'd end up with quite a large grouping, which could then overshadow everything else. So it probably would make more sense to combine the virgin in the other column for the other phone providers, right? Especially when you think about comparing what's going to happen if you add those together in comparing them with the other groups, okay? So you could do that, and you could argue that case. If you didn't think, it really depends upon the context, if you didn't think that grouping together 40 and over was going to be inconsistent or cause any kind of bias, natural bias, then it might be all right, okay? I mean, you could probably argue it either way, but in this case, it feels like it's going to cause quite a large grouping. So that effect will put the virgin into the other column, and now when you do the expected frequencies, none of them are less than 5, and we're all good. Okay? That's how we deal with it. So that's it. Okay? You've just finished maths.
Go home.
No.